Wireless LAN Professionals Podcast, episode 181.
We allow you to do it like in a scheduled basis. So you can say, okay, for speed test, I want to run maybe 4 times a day, maybe a couple of times during business hours and a couple of times off hours to get some baseline there.
Wireless LAN Professionals is a place to educate, inform, encourage, and entertain those involved in wireless LANs. This Wireless LAN Professionals podcast is an audio manifestation of these goals. Our host is a wireless LAN veteran, consultant, designer, and teacher, Keith Parsons. And now, the podcast for wireless LAN professionals by wireless LAN professionals.
Keith, we got another biggest struggle question for you. This comes from Daryl, and this is a question we get a lot. And it seems like it is a common struggle. This is my biggest challenge is getting clarity on the requirements from the user. And I guess one of the questions I have kind of follow up, not to put words in Daryl's mouth, but a different angle. Is there personality issues or soft skill things that maybe can help them in communication? Because I know you've answered this with, how to think about Wi-Fi, what kind of questions and mindset you need. But what about those actual soft skills of being the kind of person who gets that from people? What would you tell someone in that kind of situation, or how to develop that part of the asking piece of it?
Very good question, and thanks for asking it, Daryl. I think the soft skills side that you added to that, Matthew, is really important. So important that many systems integrators and value-added resellers, instead of sending engineers out to collect these questions, they send out a salesperson with a little punch sheet, a little list of questions. And the salesperson asks the questions because they're really good at that interface and talking. What the salespeople are not good at is pushing back to the customer. Now, engineers are a little anal at times, can be, and not always good at the communication side. So I understand why a systems integrator would want to send a salesperson who's nice. But salesperson's favorite word is yes. When they ask a question, they love the customers to say yes. Can I get a PO? Yes, that's what they want to hear. So when they're on the asking side, they like to get to yes. So they say something like, where do you need coverage? And the customer says, everywhere. And the salesman just checks and writes, everywhere. Not knowing that, to add to stairwells and elevator shafts, you might add 40 to 50% of your additional cost. Now, they never stop and push back to the customer and say, are you sure you want to pay 50% more to add just stairwells and elevators? And they don't get to the details. And because they miss the details, later the engineer gets sent this scope of work that says, we want coverage everywhere. And they have already said, well, we did some quick math, and so we divided the number of square feet by 2,500, and that's how many APs you have. And not knowing that 40% of those are going to just be in elevators and stairs. So I think maybe a good combination, if you're not the sales guy, but you're the engineer guy who's going to have to do it, is tag team when you go out on those sales calls. Learn from the salesman the techniques they use in asking the questions, but don't allow the salesperson to just roll over and play dead. When you have a serious piece of information you need to know, like how many clients do you have? What are the applications the clients are running? What type of clients do you have? What are your future going to be? Those all are very pertinent and will change the outcome of the design. So you can't allow them just to go, all clients, check.
Yeah.
We need to get down to the details. So maybe piggyback with the salesperson, or give, if you have a checklist that it means it looks like you're working for something organized, that you're not just, coming off the top of your head, I think you should do this. And you're saying, do you have, have a process? And the customers will probably like that process a little better. Not all customers like it though. I know a lot of customers just want to skip right to the end and say, well, just do it. And as an engineer, you have a little more tougher time.
Do you have a document that you use, or is it just so ingrained in your experience that you know what to ask based on the situation? Have you used a cheater sheet in the past? Do we have that on the site?
I use them all the time, and they are not to be shared.
Okay.
It's definitely very proprietary information.
Okay.
Years ago, I went on a quest to go and build the master sheet from everyone. And I talked to a whole bunch of people who have really good intake documents, is what they call them. And everyone said, not a chance. That's our secret sauce. That's how we make our money. So getting a hold of one, there's some generic ones. If you get in the back of the CWNA or CWDP manuals, there's some generic ones. But building that list, and the problem with my list currently is 24 pages long and single spaced. So it's got the issue is when I sit down with a customer, I use it as a checklist. But either before or sometimes when I'm even live there, you have to adjust the list. If there's a whole section on voice, and if they say we don't need voice, then I can skip that. Or on the section on voice, they say we need voice, but we're installing a Cisco handset. Well, then there's a whole bunch of things about ASCOM and Avaya and the other vendors that I don't have to ask. So yes, I have a very, very detailed list, but then the use of it is paring down to ask only the questions that are important for that customer.
So it sounds like a good goal for maybe Daryl or anyone in the situation is spend time, maybe you and the sales team, and create the intake document that makes sense for both parties.
And just make sure that you don't, as an engineer, let's just back up for a second. If you're an engineer and you went to a customer and you were a structural engineer, you're trying to design the beams that go over and hold the roof up. If you went in and you ask a simple question like, how many floors is the building? And they went, oh, no, just design each floor. We don't know if it's going to be a 5-story building or a 7-story building. It's really important. Now, you could over-engineer and put huge ones saying, maybe it's going to be a 20-story building, maybe it's only going to be a 10. Now, I've been in places in the world where they build a 2-story building, and then you see on the roof, all of the rebar is poking up. So they designed it to add another floor on top when they get enough cash. They don't have enough cash, so they only built a 2-story building. But they designed it for a 3 or 4. We need to ask those questions. You would never allow a structural engineer to get away with, I don't know how many floors it is, but somehow our customers want us to get away with, oh, well, I don't know what the Wi-Fi clients are, any client. So I think if we give them some examples of other engineering issues that they've already done, kind of like, and this is kind of an aside, but some of our customers are like, well, I don't want to pay for design. And you're like, so the architect who designed your building, you didn't pay him? Paying for design is a thing. We do it everywhere. Yep. And then we get someplace into wireless and some installer or some salesperson says, oh, no, we'll design it for free. I admit sometimes I do designs for free, but that's only for the people who buy the hardware from me.
Yeah.
If they don't buy the hardware, you got to pay for the design.
WLAN interview.
Welcome, Keith Parsons here with Wireless LAN Professionals Podcast, and today I have with me Panos Vouzis. I think I got that right. How are you doing today, Panos?
Great. Hi, Keith. Thanks for having me. You got it right.
I got it right, yes. Hey, I've been to Greece once and didn't learn any Greek at all, so, but I at least got your name right. So let's get started. You're with NetBeez. NetBeez has been in the I don't even know what you put the category in babysitting and managing and monitoring Wi-Fi for a long time. And you have some new stuff out. So I thought we'd get you on the podcast and talk a little bit about your 1.5 release and hear about all the new stuff you've got going in NetBeez. And also I wanted to congratulate you on some of the things you've been posting lately that I liked. So are you good with that?
Great. Of course. Let's get going.
I just wanted to congratulate you or thank you or give you kudos. I think your series that you've been posting lately on Linux steps for the wireless professional have been a great resource. I save them, I capture them, print them out, and I have them on my iPad. So I think that's a great resource for everyone. What was your idea about starting that whole series?
Definitely, yeah. It's been a very successful series of blog posts. We've been very active in blogging in general since we launched our, endeavor here. And the thing is that, in our product itself, we use lots of open source software, and of course, Linux is the base of our, product for everything now, right? The sensors and the server we're using. And of course, we develop a lot in Linux and a lot around doing networking stuff on Linux, right? We have to manipulate interfaces, do routing on the Linux box, do Wi-Fi surveys and scans. And of course, I realized at some point I learned so many things during this process myself. And it really would like to share it with the community. So I try to, it's every other week actually. I take turns with my co-founder in blogging. Every other week I try to put out a blog post around Linux for network engineers. I deal with things like how to configure things like a DNS server, how to like manipulate the interface, and some more advanced stuff like to write even the bash script, right? To introduce people to automation and get their hands dirty with some programming. And it was my pleasure actually to present at the WLPC this year, like an introduction of how people can get into Linux, right? Of course, I wasn't expecting 20 minutes to teach Linux to anybody, but I just want to give some pointers, and people can follow up on our blog post and learn gradually things around Linux networking and Wi-Fi as well.
We'll have links over to your blog from the podcast, but highly recommend anyone who wants to learn a little bit or even just play with it, go over to the blog that Panos has done, and you can start easy and learn as much as you want about how Linux works. But kudos that you took the things you learned in developing your product and sharing it with the community. That's well done. Well, let's talk about your hardware. You had hardware running on like a little Raspberry Pi for a long time, but you now have some new versions. Tell us about the different sensors that are available from NetBeez.
Definitely, yes. And I can go a little bit back here now, take a step back. When we started NetBeez, actually, our co-founder, Stefano, was a network engineer. He wasn't really a Wi-Fi engineer. So our first sensor was a wired sensor, right? And of course, when we showed that to customers, to first beta users, they were asking about, hey, okay, that's great, but let's do the same on Wi-Fi. So we realized there was a big opportunity there, and we jumped into that, space. So from the very beginning, we have used our first platform actually was the Raspberry Pi platform. Many people are familiar with that. Very versatile and low cost, actually, right? Hardware that runs Linux. So that's where this comes in, right? So it's a Linux box that you can do so many different things with, right? And you know that very well. The community has endorsed and they used a lot the NanoPi, which is a similar platform. So we use the Raspberry Pi as a sensor for Wi-Fi. We use some extensions and some other hardware to make it 802.11ac 2x2. But also we haven't forgotten our roots. We have both wired and Wi-Fi sensors. So for Wi-Fi sensors, we use another platform which is also off the shelf, runs Linux, actually it's an interesting platform because it's an x86 single board computer. And I'm mentioning this because most of these, for example, the NanoPi or the Raspberry Pi, are ARM-based computers. With the x86, you get some additional benefits in terms of what Linux distributions you can use, and I would say a little bit more better support in updates and new distributions. It's been a great platform, and we'll keep evolving, exploring the community, and looking actually at new hardware right now that we may release in the next couple of months.
So do you have to keep different code bases that run the NetBeez sensing app depending on the platform? Or is it you have one consistent code base?
So the code base is the same. We develop in a way that we can support the different platforms, our software. So the code base is the same, but with some modifications, of course, to make sure that it's compatible with the different versions. However, we also have, just an example, right? We also have out like a Debian package that customers or people that want to try our product, they can use and install it even on their own hardware, right? If they have, let's say, an Ubuntu server or their own Raspberry Pi, they can just download our Debian package. And of course, that supports the different architectures, ARM, 64, 32, AMD, like x86, I would say, 64 bits, right? So we make all those available, and for our production, of course, we prepackage everything, but also we have the option for users to use our open source and free software if they want to.
So if you're open source and you allow that free software, what's your business model? How does NetBeez how do you earn a living there?
Yeah, definitely. I mean, the value we add mostly is, of course, the sensors is the essential part of the product that you need to monitor, place at the different Wi-Fi locations and monitor the user experience. But most of the value is derived actually from the dashboard, right? So all this data that you collect from the different sensors on your network are being collected on our dashboard. It can be on the cloud or it can be on premise, and that's where all the, I would say, magic happens, right? All the data is collected, statistics are being calculated, all the user management that to manage their fleet and the swarm of bees, right? To perform the necessary tasks and monitoring they want to do on their network.
Okay, you just got me now. I'm totally admitting this. This is the first time I got bees when you said swarm. Cool. I'm really slow. I didn't see any little bee logos on your webpage or anything, so I've just thought it was a bees. Okay, you got me now. So if you were a end customer and you wanted to put these sensors around in your network, what's the kind of pricing model that you'd be looking at, both the cost of the sensor but also the cost of the dashboard?
Right. So the pricing is based on the number of sensors you get. To give you an idea, I mean, the starting price, you gotta get a minimum package of five agents is $3,600 per year. That's for 5. You get the hardware. So the hardware is included in the subscription, and it also includes the server and the dashboard, right? Now, of course, there's if you go to larger number of agents, and most of our customers that are like medium to large corporations, that's when the need for NetBeez comes in, right? When they have multiple locations, dozens or even hundreds of locations that they have remote workers, they don't have local IT to help them support the troubleshoot Wi-Fi and wired networks, right? That's when you can install dozens or hundreds of these devices, the sensors, to get a complete perspective of your Wi-Fi network. You can do monitoring, alerting, baselining, and be able to be on top of things before your users complain. So, of course, there the pricing is different, and it scales based on the number of agents in a way that makes it affordable and without breaking the bank, right? To install even hundreds of these sensors without having to, pay an arm, right?
So if you're wanting to watch your Wi-Fi and you put in one of the sensors, one of the questions we get with any kind of overlay system is, what's the ratio of sensors to access points? I know it's not an easy question, but we get it all the time. So
also our customers ask us about that, and like the answer, it's so many in life, right? It depends, right? The biggest, I would say, the first starting point is we work with the customer is that you need one per location at least, right? So of course, that's if you want to monitor specific location, you need one sensor there. Now we have, again, let me go back a little bit. On the wired side, usually you want to have the perspective of both, right? If you want to make sure that a problem comes on the Wi-Fi side, on the wire side, if it's a backhaul problem, it's advisable to have also a wired agent at its location. So one wired agent at the core router is probably enough in that case. Some people want to go more granular. They go one per IDF, for example, right? But depends, how granular you want to be, right? Now, on the wireless side, things are a little bit more, of course, vague. We start with the advice to think about your high concentration areas first and the high value areas. So the boardroom, the C-suite, right? A big auditorium, probably are locations where you want to install at least one agent to make sure that you cover a big chunk of your users. So that's one thing. And then the other thing is that problematic areas. So if you have specific locations where you might have interference, you might have many complaints from users, and you're going to keep an eye on them, then that's another location where you can install an agent there to make sure that you have that perspective on your dashboard. So these are, I would say, the general high-level rule of thumbs that we go with our customers when we do our solution planning. And then, of course, the more granular you want to go, it's easy. The solution is scalable. The backend is scalable. You can add agents depending on how important your infrastructure is, and of course, how well you want to monitor your network.
So if I've got a NetBeez solution in, let's say I'm a hospital, and I, take my MDF as one, each of my IDFs have one from the wired side. I spread them out maybe one every 10 APs just so I have a tendency there. The reporting that comes off of that, how did you get actionable items from there? So you're not going to be able to tell if I have coverage, but you'll be able to tell if systems go down. So what's the actionable items that come off your reporting?
So the data we collect give you the ability to monitor user experience, right? So you, of course, again, as a hospital, let's say, you have certain specific applications, let's say, and resources that all your nurses, doctors, but also guests want to use, right? The guests want to use the internet and all the entertaining stuff, and patients, and then your employees want to use all the internal application resources, right? Even VoIP, right, over is important, an important resource on hospitals. So you're gonna make sure that your sensors simulate user experience and monitor and check continuously the same resource, the same applications that your users need to use, and make sure that you put, for example, of course, how quickly you want to get notified when something goes wrong, right? Of course, some intermittent issues may be acceptable in some locations or some applications, but some may not be. And the simplest thing we can do, of course, is to send you an alert when let's say you have a performance degradation. If your response time to a specific critical application increased by a certain threshold, let's say goes above 2 seconds, let's say, right? Or drops completely, right? Then the simplest thing you can do is you can receive an alert, notify your NOC center, your network engineers, through many different ways, actually, right? It can be email is the simplest. You can integrate with other things like PagerDuty, Splunk, or even Slack, right? So now Slack is everywhere. If your NOC team is on Slack, you can send your alerts on Slack, and you can even get them there so that the whole team can see them and discuss around them. And going a little bit more advanced, apart from a simple alert, we have what we call incidents, where you can set certain thresholds in the sense that, let's say, if I lose 80% of my applications, right, or even 10% of my applications are not responding or have low performance, then I want to receive an alert. So that filters down a little bit, I would say, the number of notifications you may get. Of course, we know everybody knows about the alert fatigue. Everybody has now a number of monitoring tools in their arsenal, and they're receiving alerts from everywhere. So the incidents we have, the incidents mechanism, allows you to filter down a little bit the alerts you get and customize them to your needs, actually.
Well, let's move on more to the business side of NetBeez. The technical side kind of makes sense. People understand you're running some level of synthetic testing to test VoIP or speed test or iPerf, and then you can report on them. If you were going into a new customer, and since we have thousands of people are downloading these podcasts, you have some potential customers to talk to. How would you sell a NetBeez solution compared to your competitors? Competitors being no sensors, just using what's inside your controller, versus your competitors who have sensor networks, YBot, CAPE, or 7-signal kind of thing. How do you go about saying why NetBeez is better? Give me your sales pitch.
The first thing you have to think about is we give you the ability to cover both your wired and wireless network. So we have both types of sensors, and not only that, we have virtual sensors. Now we just released actually our Docker sensor and also cloud sensors. So especially with the Docker sensor, what you can do right now, of course, Docker is exploding. You can install quite easily actually a sensor on a user's laptop, right? Of course, we have the hardware piece, but sometimes when you get that perspective per user experience with a Docker sensor, you can get somebody's laptop and spin up a sensor, right?
Just a technical question to insert there. If I'm running Docker, let's say I'm on a MacBook, is it using the MacBook's internal Wi-Fi and reporting back what it sees?
So for the Docker now, we just released it. It doesn't capture the Wi-Fi metrics. It doesn't capture things like we do with the hardware sensors, like signal strength or link quality. But it gives you the user experience in the sense that you can do the application verification. You can do, for example, you can do a speed test, right, to see what performance you get, right? In a future release, we'll be able to capture all these metrics as well from the Docker container and present you the Wi-Fi visibility of what you see on your Mac or your Windows machine.
Okay. So continue.
Yeah. So we have this complete picture where you can install these different sensors on every edge of your network, right? Wired, wireless, end user device, cloud or virtual. Actually, right now we're going to Cisco Live next month, and we're having a joint session where we're also talking about how to install an agent on the CAT 9000 Cisco switch and infrastructure now, and the whole DNA thing they're promoting. So we'll give you the complete picture of what's going on in your network. You can cover every edge and every corner. Now, the solution we have for the server specifically, we offer both an on-premise and a cloud dashboard. We still have many customers that are very security aware, right? And they have very critical applications, and they most of them prefer to go with the on-prem solution because they still, are not fully cloud, I would say, cloud enabled, right? They have still restrictions because of compliance issues and all these things. And so with all that infrastructure we support, we have the ability to give you a complete picture, and also having this software version of the agent will give you the ability to scale that to hundreds or even even thousands of agents if needed, right? On a software basis, which makes the solution affordable and scalable from a pricing perspective. Not hardware is not necessarily always needed if you can solve your problem with a software agent, let's say.
So one of the questions is there a way to set up the synthetic testing timing? If we're running iPerfs or VoIP testing, we don't want to load up the network excessively, but we'd like to know how it's going. What's the control you have over the timing of those synthetic tests?
Especially with the test you just mentioned, maybe iPerf and speed test, especially, right, where you really stress your network. You want to be a little bit careful. You don't want to run an iPerf or a speed test every minute, right, on a network, and then defeat the purpose of monitoring. So we give you, first of all, we make sure we have a mechanism that we make sure that you don't run more than one of these especially high-performance speed tests and that are high demanding tests per agent, right? So we have a blocking mechanism that you can run only one per device at any given time, right? So you cannot really even accidentally flood your network and break things. And then we allow you to do it like in a scheduled basis. So you can say, okay, for speed test, I want to run maybe 4 times a day, maybe a couple of times during business hours and a couple of times off hours to get some baseline there. While with the other tests, the like latency test, HTTP test, or DNS test, you can run them much more often. Actually, most of our customers run them like every few seconds or a minute. Because, okay, doing like a DNS query, it shouldn't be like an issue, right, on your network. Shouldn't put any stress on it. Those are okay to run them quite often, actually. But yeah, I mean, as you mentioned, we have mechanisms that give you the ability to schedule them in a, like I would say, a time-spaced fashion. And also, we don't allow you to break your network accidentally.
Well, that's nice that you're being protective. On configuring the Wi-Fi side, obviously the sensors need to connect up. Do you support WPA 1, 2, 3? And how do you go about choosing what EAP methods so that your sensors can act like our clients?
All the agents are managed from the dashboard, so the configuration of the credentials for the agents are managed from the dashboard. So at least the first time you connect them, a Wi-Fi sensor, you have to connect it to a drop, so it can connect to the dashboard, right? Then from there, you can connect on it and configure its credentials. Yeah, you can support .1x, of course, and all the different methods that are available are on our dashboard. So you can choose them from a menu, upload your credentials, keys, certificates, and then everything is automatically, assigned to the agent so they can connect to the right network. So that's how you configure them. And we also now recently, actually in version 1.5, we introduced the option to monitor multiple SSIDs. What that means is that when you have an agent, of course, as a client on your network, and you have more than one SSIDs, at least right now you're gonna have 2 or 3 in any enterprise. You're gonna have a guest network and then your internal corporate Wi-Fi networks. We give you the ability to do what we call SSID hopping. So you're able to configure different profiles for each SSID. Let's say if you have an open guest network, then you can configure one profile according to that. If you have your internal WPA2, etc. profiles, you can configure them again, and then you can tell the agent, hey, I want you to monitor for 5 minutes my guest network, another 5 my guest network, and another 5 minutes my internal corporate network, for example. So you can do all this from the dashboard, of course, and without having to touch the agents, obviously.
You mentioned guest network. Do you have the ability for your sensors to join a guest network with a captive portal and get past the captive portal?
Right now, we don't have this ability. You have to whitelist your sensors from your controller, let's say. But it's something that is coming up in our next couple of releases, actually.
Well, Panos, I appreciate your time today, sharing us a little bit about where NetBeez was and where it's going, and what you're doing with it today. If someone wants to get a hold of you or NetBeez, where would they track you down?
Yeah, thank you for having me, Keith. So you can find us at netbeez.net. There you can learn about our product. You can also, as Keith mentioned, we have a very active blog there. We talk about Wi-Fi issues. We try to share what we learn at work. And we're also going to Cisco Live next month. If any folks are there, we're going to be at booth 3234. Come stop by, say hi, and we can chat.
Great. I appreciate that. We'll put links in the show notes to your site. And especially, I want to renew my gratefulness that you've started putting your blog posts, sharing what you've learned out with the things. And I just noticed you even have a how to install the NetBeez Docker agent on a MacBook. I think I have something to do this weekend.
You got it.
So thanks again for your time, and we'll see you on the web. Hopefully we'll see you at the WPC as well.
Of course. Thank you, Keith. Have a good one. I'll be there.
10 Talks.
How's everybody doing? Mike Albano. There's my email, Twitter, what have you. I'm just going to jump right in. I work for Google. I'm on the enterprise side of the house. So we handle the deploying and monitoring the network for Googlers. So here's the agenda for the next 10 minutes. I'm just going to go into how we used to do it, disadvantages of that, what lessons learned, what have you, and how we do it now. And the goal is that he would agree that how we do it now is better, but we'll see. All right, so very loose dress code at Google. All you have to do is wear something, so I got away looking like this 7 years ago. So yes, it was build rooms, documents with standard configurations. It was entirely CLI driven. We had a lot of employees that all had access to the infrastructure to do both the deployment and the monitoring. We were using vendor NMSs, such as Prime and AMP, to monitor the network. And we had a sort of host of other tooling that we used as well. Open source tooling, Rancid, Nagios, what have you. I'm sure many people in the room have experience with that stuff. And it was pretty much dynamic everything. No automation, we deployed a vendor. All right, so then a couple years later, we got rid of the documents and we started using config generators to try and come up with a little bit more predictable way of generating this configuration so that we could have, the goal was obviously having the same configuration on a lot of different devices. Got rid of the vendor NMSs and we were starting to experiment with graphing the telemetry ourselves, the radio data, the stuff that we all need and use to monitor the network. How are we doing that? The same way everybody else, SNMP, and a lot of scripts, a lot of CLI screen scraping, having scripts that log in, do some show commands, stick it in a database, a lot of scripts. Moved on to static transit powers. We were still doing dynamic channels. The goal there was we weren't ready to approach static channels, but we absolutely wanted to control the size of our cells since that's what we designed the network for. Still deployed a vendor and still relatively little automation, just some. I mean, kind of depends. Automation is a very broad term. We were using config generators, so you could say that was automation. All right, so there was a lot of problems with this. It was a highly distributed network, a lot of buildings, global, blah, blah, blah scale. A lot of the problems were caused by us, the humans. There's a lot of outages caused by just having such a distributed model of all of these systems, and everybody had access to it. And there was never any nefarious activity going on. It was just that, people make mistakes or they think they're helping and they're hurting in other ways. So, yeah, it was problematic. It was kind of the Wild West. So, what did we want to change? I should say that no human was fired during this transition from when we went from doing it one way to another. So this is kind of in jest, but we sort of stepped back and said, all right, here's the lofty goals that we want to solve. What are all these problems of doing networking the way that we have been doing it for so long? How could we do it differently? What would we fix? What do we want to tackle now? So, all right, so one, we know we needed radio data. We know we needed telemetry, and we needed it fast. So SNMP wasn't working. You take a lot of data, like whether it's 802.11 retries, channel utilization, what have you, you aggregate that out to 15 minutes and it becomes absolutely worthless. You mask the spikes, you can't see what's actually occurring in the network. If it was a problem for 1 minute and then great for 14, then you don't know what happened. So we need radio data, we need it fast. We needed freedom of choice, so we wanted a multi-vendor network. We wanted the ability to do what we had heard about, which was align a vendor to a use case, whether it's through some software or hardware differentiation. We wanted the ability to choose a vendor based on our needs, but we couldn't do that, not at this scale, not without translation layers. So real quick, translation layers is basically taking a proprietary MIB or a proprietary CLI interface and then translating that to something neutral on the back end. But those translations layers are something we had to maintain, and that was problematic. We wanted APIs for everything. So we no longer wanted SNMP. We no longer wanted to be doing scripts and screen scraping and all that stuff. We wanted everything to be programmatic so we could automate it and be more predictable. That's the fourth one, absolute predictable configuration. Just because we think we configured something one way, we needed to know with 100% assurance that it was still configured that way, and there's many reasons for that config to drift. So those were the goals. There are always humans. We figured, okay, if we're going to go down this path of automating everything, what should we not automate? And the design was a sort of a clear one that you wouldn't automate, right? We're always going to have humans generating those heat maps, figuring out where the APs need to be placed. Dots on a floor plan, channel, transmit power, typical wireless LAN design stuff, right? That we all do. So what we thought we'd do is treat this heat map as the one true authoritative source for everything. So the heat map is the only thing that humans touch. In fact, that's how we got to here, which is basically the only way we deploy networks now is that we have the heat map, which a human generates, and that is it. Everything else is automated through APIs. So we use slides just because we needed we just needed something that we could stick a floor plan on, put some dots on it, and a label for the typical 5-layer stuff. Channel width, transmit power. So we use slides because it has an API, and we could feed back into that. So we access the API, we get our AP name, we get all our 5-layer stuff, and then when we do our channel planning using neighbor tables, again, telemetry, RSSI neighbor tables, we come up with a quick channel plan, and then we do puts back into that same API so that the heat map gets updated with what channels we've selected, the 5-layer stuff that we've selected. So what this means is the network gets deployed without a single human logging into anything. No logging into a CLI, no SNMP rights. It's basically a script that gets run after the things are physically mounted. Nobody logs into anything. And on the operation side, when we're monitoring it, nobody's logging in to anything. It's all abstracted by the operations staff. And that was important for us. We couldn't retrain our NOC and our operations and our engineers for every vendor's interface. So I'm going to race through this. Obviously, I'm here to talk to people, so please come up and shoot holes in my theories and ask me more questions about how I do this after. So yeah, we monitor stuff in a vendor-neutral way. We've got graphs. But we're accessing the APs programmatically, getting the telemetry we need, populating a graph, and this is the same amongst all vendors. So we deploy multiple vendors without our NOC or our operations staff even knowing which vendor is on the ceiling. Nobody knows. That's sort of the mantra there, and that's the way we truly reach this multi-vendor environment, both deploy and operations. Unless it gets escalated, unless it's a vendor-specific software bug, they never know which vendor is getting deployed. All right, so what does this get us? Well, it pretty much gets us to those high-level, lofty goals we wanted. So the way we do that is I sat on this stage like 2 years ago, and I was presenting on this thing called OpenConfig, which is, the short version of that is it's a bunch of network engineers that get together and decide what a schema should look like, what the API should look like to network elements. And 2 years ago, it was just a theory. I was sort of saying, hey, do you guys think this is a good idea? Then I went and talked to a bunch of people, some of them in this room, came up with these Yang models, which is the modeling language we use to define these APIs. And now it's a thing, and multiple vendors are supporting it, and we use it to deploy our networks. So that's how we got the multi-vendor aspect. There's some data points there about how much better it is now, and it's obviously a lot faster to deploy, easier to monitor, no build rooms, no docs. We use 0 vendor proprietary tools, and that's pretty much about it. We have an app that helps us with scanning of MAC addresses for mounting. A lot of people have done that. That's pretty much it. Yes, it is a Wi-Fi conference, so I like throwing out argumentative statements like static, everything, everywhere, all the time is better, always. We found it way more predictable and a lot easier to operate the network.
Thank you for joining us for another episode of the Wireless LAN Professionals Podcast, the podcast for wireless LAN professionals by wireless LAN professionals. Be sure to follow us on Twitter at Wireless LAN Pros for all the latest news and updates, and also connect directly with Keith on Twitter at Keith R. Parsons. Head over to www.wlanpros.com for this episode's show notes, as well as the latest in all things Wi-Fi.